Hi, welcome to this recording on how to use Excel to create your density graph. And so when you get to this point in the lab where it says data table 2, you're going to use this data here that's listed in the table to create your graph in Excel, and then copy and paste your Excel graph back over here into the Word document. So I'm going to go ahead and show you how to do that. I'm going to use a different set of data, so I'm not doing the same one that you are. But again, when it's time for you to do this, you want to use the data that's here on the lab document. So anyway, the first thing I'm going to do is open up Excel. In creating graphs in Excel, you may have done this already before, but it is a really good skill to have to be able to create graphs and manipulate them in Excel. And so the way Excel works is that you want to line up your data, X and then Y, because we're going to highlight it and ask Excel to create our graph for us. And that's the order they have to be in order for the graph to come up correctly. We also are going to use the slope of the line in order to determine our density. And so density is mass over volume. So slope is y over x. So that means we need our y-axis to be our mass and our x-axis to be our volume. So we get the mass over volume, we get the correct slope in the density equation form. So my x values are going to be my volumes. So I'm just going to put volume here. Again, so we keep it straight while we're in this recording. But when you're doing yours, you really actually don't have to do any of this. You just need the numbers for Excel to graph it for you. But again, you should always put the volume, then the mass, or the X values that you want, and then the Y values that you want. So the data I'm using is density. I'm trying to find the density for alcohol. So I have 10, 20 milliliters, 30 milliliters, 40 milliliters, and 50. And my masses are 7.59, 15.1, 22.8, 30.6, and 38.2. What you don't want to do is do something like this, where you're putting in the units, because then the graph won't work. So you only want numbers in your data chart or your data table. And that's why usually when you have a data table, you put the units at the top of the column so that it's not with the numbers within your data. Right. So now I want to create my graph. It should be a straight line. We're trying to form a straight line graph. And when you're looking for a best fit line or a straight line, the best one to use is the scatter plot. And so what I'm going to do is highlight my numbers. This is what I want to graph. And then I'm going to go up to Insert. And I have all of these charts to choose from. This last one here is your scatter plot. So I'm going to click on that one. And I'm just going to choose this first one. You could see if you kind of slide over in these other scatter plots, they're already putting lines in there for you. This is kind of like 3D bubbles happening down here. The best one to use is this first one. That's the one I always use anyway. So I'm going to hit that first one, and now I have my graph. And so now I just have to clean it up and add in all of the stuff that I ask you to do on the lab. I'm going to hit this plus sign here. You could do it here or in Excel. I may be off of the screen right now. It may be off of the screen right now. I'm not sure. But if you click on your graph, you could click on this plus sign and you could choose what you want to add to your graph. Usually up in your toolbar at the top, it's in the top right or the top left-hand corner, and I'm not seeing it right now. So again, it may just be off of this my recording screen. Anyway, you can click on your graph, click on the plus sign. I want my axes titles, so I'm going to click on those. My chart title is already there. And I also want my trend line. So that's going to create the best fit line through my data points, which looks to be pretty good. So I'm going to click that one. So I have my chart title, my axes titles, my trend line, and then I also want my slope, or at least my line equation, and my R-squared values to show up as well. So next to trend line here where you have the arrow, you're going to click that. and then go down to more options. Let me see if I can open the screen a little bit because that's kind of off of the screen as well. I may have to, oh, I could just scooch it this way. There we go. All right, so clicking on the chart title, the plus sign, I have axes title, chart title, grid lines is fine. It gives you the background, the trend line we want. And now I'm going to click this arrow and go down to more options. Let's see if I could scooch this over a little bit more. There we go. And so under more options, you'll get this bar to pop up. I'm going to scroll down and click on display equation. That's going to give me my line equation, my y equals mx plus b equation on my chart. And I also want to click display my r squared value. I'm going to talk about the r squared value in class, and I'll talk about it a little bit here. We're not going to do anything with that, but again, it's just another good practice to have or to understand what the r squared value is if you haven't seen it before. So we're done there. And now we just want to add in this information. So my chart title is going to be density so yours is going to say density of aluminum. I believe I have on your lab document, and it's good practice to put your axes in the title as well. So it's going to be mass versus volume. I'm going to put in my axes titles. And when you're putting in your titles, again, you should include units. So I have grams in parentheses there. And at the bottom, I have my volume, and that's milliliters in parentheses there. So my chart title, I have my axes titles with the units. I have my trend line. I have my line equation, and I have my r squared value, and that's all you need. So I'm going to go ahead and copy and paste this over into the lab document. But before I do, I'd like to highlight that a line equation and the r squared value really quickly before this recording's over. That line, y is equal to mx plus b, is the equation of a line, right? And in that equation, the m is your slope. So I'm looking at my equation that's telling me that 0.7672 is my slope because that's where my m falls in my y equals mx plus b equation. You're going to do the same thing. You're going to need to get that slope value to do some calculations on your lab. So it will be the number that comes before the x value, right? Because that's the slope in the line equation. And then real briefly, this r squared value here is perfect. I should have skewed the data a little bit. But what the r squared value tells you is basically how good your data is, or how close to the line your data points are. And it doesn't have to be a straight line. It could be the graph of whatever your graphing, curves, lines, whatever it happens to be. The r squared tells you how good the data is. And the closer you are to 1 or 100%, if you're going to do it in percentage values, the better your graph is. And that's as high as you could go. It'll be a value between 0 and 1 or 0% to 100%. And so the fact that I have a 1 here tells me my data is perfect. You can see the line is going straight through all of my points there. So my r squared value is 1. Again, we're not going to be using it in our lab, but it's a good practice to take a look at it and say, oh, how good is my data? You know, how close to that line? How much error do I have basically in my data? Let's change one of these points just for giggles. Let's see if I could get the R value to change. Let's put 60. There we go. And so you could see now I changed one of my data points, which by the way, automatically updates your graph, right? So you can fix it if you need to that way. But you could see my r squared value now went down to 0.64, which is 64%. And so it went from 100% to 64%. And you could see now that line isn't touching all the dots, right? It's the best fit line. So the Excel program or the computer draws the line that is closest to all of the points. So between them all. And in this case, we have a lot that aren't on that line. And so again, my data is kind of so-so at this point. 64% is not that great, right? The closer you get to 100% or the closer you get to 1 is the best. And again, it's just a good value to look at to see how good your data is. All right, so let's put that back to where it was. And also too, let's say you wrote the wrong data points in, or you want to add a data point. You can always just click on the chart, and you can right click and you can go down to your select data. And right now you could see what's highlighted in my data. If I wanted to change it and only do 4 points, I could do that. And it will fix my data for me and so forth. Right? So if you click on the graph, you should be able to have pop up anything you need. To just review one last time, click on the graph. I click on this plus sign. I'm able to choose everything that I want to have in my graph. And then near this trend line, you're going to have to choose that arrow, more options. And then from there, you could scroll down and hit display your equation, display your R-squared value, and close it up. So now all I have to do is highlight it. I'm going to screenshot it. So if you could see what I'm using here, I'm using the Snip and Sketch tool. If you haven't used that before, you could search it on your computer. It'll be there. I'm going to hit this new button. I'm going to highlight just my graph. That's all I need. Copy it. And then go over to my Word document. Hopefully it's right there. There we go. I'll scooch it over for you into the screen. Go over into my Word document and I'm going to paste it right where it says paste graph. And there you go. Then you're done, right? So you have your graph in there. And then as you scroll down, you'll see, push it back up there. You see it asks you to calculate your percent error, and your experimental value is your slope. The accepted value is going to be this 2.70 in the problem. And you just have to plug it into that equation. Alrighty, hopefully that helps. Good luck with your graphs. And if you have any questions, let me know.